Algebra 1, section 2-6. We are looking at ratios and proportions. Ratios and proportions. So a ratio this is a comparison of two numbers by division. Comparison of two numbers by division. So what does this look like? It could look like this. X to y. It could look like x to y like this. Or it could look like x over y like that. So these are all different ways to say the same thing in a ratio of x to y. So let's look at another little bit of an example here. So if I have 0.349 restaurants in some area per 10,000 people. And I want to look at this ratio in a little bit different way. What I do to the bottom, I do to the top. So I'm going to multiply the top and the bottom each by 10. And notice how my equal sign is here. If I multiply each of these by 10, I get 3.49 restaurants to 100,000 people. So what I'm illustrating here is that the two ratios are equal. So a proportion is what we're looking at here. This is a proportion. I've got two ratios are equal in an equation. So this is equal to this one, as long as what I do to the bottom, I do to the top here with multiplication. The equal sign is true here. This ratio equals this ratio. Let's look at an example here. We're going to determine whether the ratios are equivalent. We're going to determine whether these ratios are equivalent, whether they are proportions. All right, so 1/2 equals 3/6. So are these fractions, are these ratios equivalent? Well, let's see. I can divide the top and the bottom both by 3 for this one, and I end up with 1/2. So yes, boom. Yes, these two ratios are equivalent. This is a proportion. Let's try this one. 2/3 equals, and we can put a little question mark here, 16 over 24. So let's try to think, how can we make these equivalent here? So, or how can we check to see if these are equivalent? There are there's one. We're looking at one way. We're going to look at another way in a minute. But let's look at this. Let's see. Okay, what does it take to get from 2 to 16? I need to multiply. What do I multiply by 2 to get to 16? I can multiply by 8. And so what I do to the bottom, I do to the top. So if, let's see, if this becomes 16, yep, and 3 times 8 is 24, oh good. Yes, these are equivalent. Let's look at two more. 6 over 10 equals, maybe, 2 over 5. Okay, so if I go from 10 to 5, I got to divide by 2. If I divide by 2, what I do to the bottom, I do to the top, I end up with 6 divided by 2 is 3. 10 divided by 2 is 5, 6 divided by 2 is 3, so I would end up with 3/5. 3/5 is not 2/5. So no, these are not equal here. Let's try this one. 1/6 equals 5/30. Let's see, 6 times 5 is going to get me 30. What I do to the bottom, I do to the top. 1 times 5 is 5. Oh look, 5 times 1 is 5, 6 times 5 is 30, 5/30. Yes, this is a, these ratios are equivalent. All right, now let's look at another way to figure this out, and it is called cross products. So here's an example. 2 over 3.5 equals, maybe, 8 over 14. So this one is a little bit less easy to kind of see than some of those other examples that we're doing. So here's what we do. We take this denominator, we multiply it by that numerator. We take this numerator and we multiply it by that denominator. 3 times 8, 3.5 times 8. And we set them equal to each other, 2 times 14. And then we see, are these going to be equal? All right, 2 times 14, that's easy, 28, right? Now, 8 times 3.5. 8 times 3 is 24. 8 times 0.5, or half of 8, is 4. So 24 plus 4 is 28. Yes, these are equivalent ratios. Let's try another one. 0.2 over 1.8 equals 1 over 0.9. Ew, gross. But let's try it. All right, let's use cross products here. So 1.8 times 1 equals, maybe, 0.2 times 0.9. Okay, 1.8 times 1 is 1.8. Any number times 1 is that number. Now let's look at 0.2 times 0.9. So let's go 0.2 times 0.9. 2 times 9 is 18. And now I've got 2 decimal points here, so that means I need to go over 1 2 times. 1.8 does not equal 0.18. So these are not equivalent ratios or equivalent fractions. Now you do this one without me. 2 over 3 equals, maybe, 12 over 18. All right, use cross products to see if you can figure this one out. And go. All right, let's multiply like this. 2 times 18. So 2 times 18 equals, maybe, 3 times 12. 2 times 18 is 36. 3 times 12 is 36. Yes, these are equivalent ratios or equivalent fractions. It's a proportion, however you want to say it. All right, let's keep moving. Solve. So I've got x over 10 equals 3 over 5. Notice I'm not asking if these are equal anymore. I want to know what x is, and this equals is true. So these are equivalent fractions or equivalent ratios, and so we can figure out what our answer is here. So there are a couple ways we can do this. One is we can try to reason this out, or we can use cross products. So let's think about it first. 5 times what is 10? 5 times 2, right? So that means what I do to the bottom, I do to the top. 3 times 2 is 6. So that means x equals 6. Now let's do cross products just to see what that looks like. So if I have x over 10 equals 3 over 5, let's do it this way. X times 5 and 3 times 10. So 3 times 10 equals 5 times x. That means 30 equals 5. X divided by 5 divided by 5. X equals 6. So either way, we got the same answer. So either way that works for you, that feels comfortable, that you're confident with, those that use that method. Now, here's where it might get a little bit more tricky. X minus 2 over 14 equals 2 over 7. This one's going to be a little bit more difficult to reason out like this, so I suggest just straight up do the cross products. 14 times 2 equals 7 times x minus 2. 14 times 2 is 28 equals 7 times x, which is 7x. And I've got to distribute that to the negative 2 as well, so negative 14. Add 14 to both sides. And I get 42 on this side equals 7x. Divide by 7. And then I get x equals 6 again. X equals 6 again. 2 answers in a row. X equals 6. All right, you try this one. R over 8 equals 25 over 40. Also do this one. X plus 4 over 5 equals 2 over 10. So do those two, and then we'll have one more example after that, and we'll be done with 2-6. Pause and get to work. All right, let's do this one first. Let's do this one the cross products way. So I can multiply like that, multiply like that. 40 times r equals 8 times 25. 8 times 25, I don't want to do that kind of math. 8 times 25 is 200. Divide by 40, divide by 40. So I can take those zeros away. I can divide by 10, and then I end up with r equals 20 divided by 4, which is 5. Or 200 divided by 40 is 5, either way. Cross products over here, 5 times 2 is 10, equals 10 times x plus 4. I'm going to divide by 10. What? I don't have to distribute it first? No, you don't have to. It's multiplication. I can divide by 10. If you want to distribute it first, we'll do that one too. So I get 1 equals x plus 4. Subtract 4 from both sides. I get x equals negative 3. Let's distribute it first here. Let's try that out. 10 equals 10x plus 40. All right, subtract 40 from both sides. 10 minus 40 is negative 30 equals 10x. Divide by 10, divide by 10. X equals negative 3. Look, I got the same answer either way. All right, last example here. And this is going to be kind of a word problem here. So in 2 years, this business opened 232 stores. If this rate continues, how many stores will open in the next 3 years? Okay, so in 2 years, we've opened this many stores. So I'm going to set up this proportion as, here's 2 years, worth of stores. So this many stores, this many years, equals 3 years and X. So how many stores will open in the next 3 years? So here are the next 3 years, and this is how many stores will open during those 3 years. So I'm going to cross multiply here, or do cross products. So 2 times x is 2x equals 3 times 232. So that is a 696, I should say. Divide by 2. X equals 348. So in the next 3 years, this business will open this many stores. Now, if I wanted to find the unit rate, something you might see here, the unit rate is when this bottom number is 1. So if I were to divide 232 by 2, 232 divided by 2 equals 116. And I could say that's 116 over 1. And so this, notice, is my, if the denominator is 0, denominator is 1, oops, spelling that wrong. Denominator equals 1, then I have my unit rate. So what I can do with this unit rate now is I can say, look, how about in 5 years, how many stores will open? I just take my unit rate, multiply that by 5, and that's how many how many stores I would open in 5 years. If I want to know 10 years, I multiply the unit rate by 10, and so on and so forth. That's what that means. That's the unit rate. Get the denominator to be 1, and then you have your unit rate. And that is it for 2-6.